In this lesson, we're going to explore solids, or three-dimensional figures. A polyhedron is a solid that's bounded by polygons that include a single region of space. The polygons are called faces. This particular one has a face on top, one on bottom, and then it's got four faces around the side. The line segment formed by the intersection of two faces is an edge. So this is an edge, so is this here, so is this, this. Anywhere where two of the faces meet is called an edge. Point where three or more edges meet is called a vertex. So the bottom, the front, and this side meet all together to form that vertex. There are different types of solids. You got polyhedra and you got non-polyhedra. Now the primary difference is that in a polyhedra, the faces are made up of polygons. So one type of polyhedra is a prism, and a prism has two parallel sides, and the pyramid, which has one side and comes to a point. Non-polyhedra are cylinders. It's not, because a circle is not a polygon, a cone, and a sphere. But we will study all of these types. Classifying solids. To classify a polyhedron, we use the shape of the base along with the type of polyhedron. This is a pentagonal prism. It is a prism because the base is a pentagon, and there are two of these bases that are congruent polygons in parallel planes. Now, doesn't have to be 90 degrees here for them to be parallel planes. It's just you've got two bases. Here is a triangular pyramid. So we call it a prism when it goes straight up. We call it a pyramid when it only has one base and goes up to a point. So the base of the pyramid in this one is a polygon. So tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. So A is a solid formed by all polygons. So it is a polyhedron. The two bases are congruent rectangles, the bottom and the top. Excuse me. So it is a rectangular prism. It has 6 faces, the 4 sides and the 2 ends. It has 8 vertices, each of these 4 corners and each of the back 4 corners, and 12 edges. You've got 1, 2, 3, 4 going around the sides here, and then 5, 6, 7, 8, and then 4 on the back would make 12. This second one has a 1, 2, 3, 4, 5, 6 sides on the base. So that is hexagon, and it comes to a point, so it is a pyramid. So it is a hexagonal pyramid. It has 7 faces, the base, and then 6 triangles on the side, and then it has 7 vertices. It's got the ones that are going up the sides, and then the ones around the edge, and so it's got 12 edges. This one is a cone, so it is not a polyhedron. Tell whether it's a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. Okay, first thing I do is I look at the base. I see the base is a square. I see that it comes to a point at the top, so it is a square pyramid. So it is a polyhedron, and it is a square pyramid. So now I need the number of faces. I've got the 4 triangles on the side and the base of the square at the bottom, so there are 5 faces. For the vertices, I've got the 4 corners at the bottom and the 1 at the top, so there are 5 vertices. And then my edges, I've got the 4 edges around the base, and then I've got 4 more edges of the triangles, so there's 8 edges altogether. This one, notice I have a curved bottom, so that is not a polyhedron. In this one, Now here's what you got to be careful. The base is not always the bottom and the top. The base is two congruent polygons in parallel planes. So my bases are these two triangles here. And since it is two bases, that is a polyhedron, a triangular prism. Now my number of faces, I've got the front, back, this top, and that. So I've got 1, 2, 3, 4, 5 faces. For my vertices, I've got 1, 2, 3 here and 3 more on the back side, so 6 vertices. And then my edges, I've got 1, 2, 3 here, 3 on the back, but I've got 3 more on the other front and back, so 9 edges. Euler's theorem. The number of faces, vertices, and edges of a polyhedron are related by the formula. The faces plus the vertices is equal to the edges plus 2. So in this cube here, which is actually a square prism, is what a cube is, a square prism, then the faces there are 6, the vertices there are 8, and the edges there are 12, and 6 plus 8 does equal 12 plus 2. Find the number of edges on the frame of this house. So first thing I need to do is think about what kind of shape that is. If I look at this end down here, it is a pentagon, and so is the other end, and so those two are congruent pentagons, so this is a pentagonal prism. Frame has 1 face as its foundation, 4 that make up the walls, and 2 that make up the roof, for a total of 7 faces. To find the number of vertices, notice that there are 5 vertices around each pentagonal wall. 1, 2, 3, 4, 1, 2, 3, 4, 5 vertices around each pentagonal wall, and there are no other vertices, so the frame of the house has 10 vertices. So, using Euler's formula, I know that there are 7 faces, there are 10 vertices, so I can solve this problem and see that there are 15 edges. Regular polyhedra. All faces are congruent regular polygons, all of them. There are 5 regular polyhedra called the Platonic solids, named after the Greek philosopher Plato. One is a regular tetrahedron. What it is it has 4 faces that are all regular triangles or equilateral triangles. A cube has 6 faces that are made up of congruent squares. A regular octahedron has 8 faces that are made up of equilateral triangles. A regular dodecahedron has 12 faces that are made up of regular pentagons. A regular icosahedron is 20 faces made up of triangles. A polyhedron is convex if any 2 points on its surface can be connected by a segment that lies either entirely inside or on the surface of the polyhedron. So if I just randomly pick 2 points and connect them, will it be running on a side or will it be running through the polyhedron? Either way, it means it's regular convex. But if it is concave, it means that if I connect this point up here and this one up here, it goes outside. So that means that it must be concave. So we want to use Euler theorems with Platonic solids, find the number of faces, vertices, and edges of the regular octagon, check using Euler's theorem. So faces. For this one, I have 1, 2, 3, 4 triangles on top and 4 triangles on bottom. So that's going to be 8 faces. I have 6 vertices. I've got the 4 around the square that's in the middle, and this one, so that would make 6, and 12 edges. There are 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. 8 plus 6 is equal to 12 plus 2. This checks. Cross sections. A shape formed when a plane slices through a solid. So what I've got here is a intersection of a plane and a triangular pyramid, and when I slice across, here is my cross section, and you can see that it forms a triangle. If I make a cross section of this cube, I'm going to get a square. If I make a cross section cut from vertices to vertices, I get a rectangle. And if I make a cross section that just slices through a corner of that, I actually end up with a trapezoid. So what you end up with depends on how you slice through that cube. Find the number of faces, vertices, and edges of a regular dodecahedron on page 796 and check your answer using Euler's formula. Counting on the diagram, the dodecagon has 12 faces, 20 vertices, and 30 edges, and 12 plus 20 does equal 30 plus 2, so it works. Describe the shape formed by the intersection of the plane and the solid. So I see here I've sliced through just this corner of the cube, and what it ends up with is a triangle. In this one, I slice through a cone, and what I end up with is a circle. In this one, it looks like this is 1, 2, 3, 4, 5, 6-sided, so a hexagonal prism, and I slice through it, and I just get another hexagon.